Welcome to University 360. In this video, we'll be talking about mechanical rotational system. Well, rotational mechanical system move about a fixed axis, and the system mainly consists of three basic elements, uh, which are moment of inertia, torsion spring, and dashpot. Over there, it was mass, spring, and dashpot. So now, let's assume if a torque is applied to a rotational mechanical system, then it is opposed by opposing torque due to moment of inertia, elasticity, and maybe friction of the system. Well, since the applied torque and the opposing torques are in opposite direction, the algebraic sum of torques acting on the system is zero. Now this is basically Newton's second law of motion. Well, we have seen the similar criteria in translation system as well. Now let us uh, now see the torque opposed by these forces with three different elements individually. Well, the first one would be moment of inertia. Well, in translational mechanical system, mass stores kinetic energy here. Similarly, in rotational mechanical system, moment of inertia stores kinetic energy. If a torque is applied on a body having moment of inertia J, then it is opposed by opposing force torque due to the moment of inertia. This opposing force or opposing torque is proportional to angular acceleration of the body. Now, let's assume the elasticity and friction are negligible. So we'll end up with this equation. Now, torsional spring. Well, in translation mechanical system, spring stores potential energy, right? Similar way, in rotational mechanical system, the torsion spring stores potential energy. Now, if a torque is applied on torsion spring K, let's assume there's a force. So then it is basically opposed by an opposing force, right, or torque due to the elasticity of torsional spring. Well, this opposing torque is proportional to the angular displacement of the torsional spring. Now let's assume that the moment of inertia and friction are negligible. So we'll basically end up with equation T is equals to K into theta. This is what I was talking about. Now dashpot. Well, if a torque is applied on dashpot B, then it is opposed by opposing torque due to the rotational friction of the dashpot, right? Now these opposing torque is proportional to the angular velocity of the body. Now let's assume the moment of inertia and elastic are negligible. So we'll end up with the equation B into d theta by dt is equals to T. So in this video, we have seen how we can, name or list out the mechanical rotational systems using moment of inertia, dashpot, and torsional spring. In the next video, we'll learn more. Thank you.